Okay, guys, this is going to be a review for your state test that's going to be coming up. This is just crash course, kind of a review of everything that we've done, putting everything in one place, and then as we do example problems in class and test questions, feel free to have this out while you're doing it. So the first thing is congruent transformations. Congruent just means the exact same, which means my scale factor is 1. A slide, so like if I had a shape and I just slid it to the other side, so like if I went this way, triangle to triangle, okay, I can go up, down, side to side. Here's my rule. Okay, x minus 3, this would mean that I would go left 3, and then I would go up 4, okay, from that. So if I had this point, again, you could take this with any of these shapes in the plane. You can just plug in -4. -4 minus 3 is -7. And then y plus 4 would be -8 plus 4 would be -4. Those would be my new coordinates. So anytime that you have a slide, so like this shape does not represent this rule, but you could go take it and then you could go, if I had a circle or whatever, I could go to the left 3 and then up 4. For this next part, if you were to reflect or flip, so like if I had the x-axis here, let's say I had the shape, okay, all I would do is I would count on my coordinate plane, like if this point was 2 units, so if I went 1, 2 to get to the x-axis, I would just go 1, 2 on the other side, and it would look like you were just flipping the thing over on the other side. So you're just counting. The y-axis would then be, okay, if I had a shape, you would flip over the y-axis, which would be here. So you'd count to that. Y equals x is going to be a slant. Okay, that goes through the x-intercept. So think about that as, you could also put that in your calculator if you were confused on what that looks like. So what that's saying is you would then count diagonally. So if I had a square, okay, it would fold over that line. So like if this was 1 unit here, I'd flip it 1 unit to the other side. So it would look something like this. Okay, but you can count diagonally to that line whenever you graph it. Y equals -x would look something like this. So it would be going downhill instead of uphill. Okay, I know I'm going quick here, but just make sure you guys have this down and I'll answer your questions. All right, whenever you are rotating or turning something, okay, any 90 degrees, all right, I've got quadrant 1, 2, 3, and 4. Okay, so any 90 degrees, the rule is you're going to flip the coordinates. Flip. So x, y is going to turn into a y and an x. Okay, so the important part is you need to remember where your shape is going to add up or end up into. So like if I go, let's say I have a triangle here. Okay, and one of the coordinate points, let's say that this coordinate point right here is 4, -5. Okay, if it asked me to rotate 90 degrees clockwise, that's going to be going this way with the clock. And every coordinate or every quadrant is 90 degrees. All right, so if I went 4, -5 to get there, I'm going to flip it. I know I have to be in this quadrant. So 4, -5 turns into negative. So there, I'm going to flip-flop. Don't worry about the signs. 4, 5 would turn into 5, 4. So this would be -5, -4 over here. I'm going to flip them. And depending on the quadrant, that's going to tell me my new coordinate, or whether it's positive or negative. We'll work on that in class as well. All right. If I go 180, this is where they stay the same. So, but you still have to know your quadrant. So if 90 degrees is, or 180 is just 2 90s. So if I flip it once for 190 and flip it again, they would be back to where it started. So if I go 4, I'm going to put this in red. So if I have the coordinate 4, -5, 4, -5, I know it needs to be up here, would be -4, +5 up here. All right, we'll work on some of that in class as well. Line of symmetry from that. Rotational symmetry means it looks the exact same after you rotate it. This would be like if I had a regular triangle like this, an equilateral triangle, I could rotate it about 30 degrees and it would be the exact same. Okay? It has to be less than 360. So you could also have lines of symmetry as well. So this is line of symmetry would be right down here down the middle. You'd have a line of symmetry. Going back to proofs, this is just some of the vocabulary. To prove anything congruent or equal to each other, you'd have to have side, 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 angle, side, angle, side, angle, hypotenuse leg, and angle, angle, side. Know each vocabulary word and what it does. Angle bisector cuts an angle in half. So if I have this, okay, and a line down the middle, angle bisector is going to cut this angle in half. Okay, so I could say those two angles are equal to each other. A midpoint or a segment bisector, okay, if I have this, a line down the middle, if this is the midpoint, I would then say segment equals segment, cutting the segment in half. A shared side or angle, this is also called the reflexive property. Okay, shared side, that is your, I think we're pretty good with this. So that would be this mark right here, reflexive property. Perpendicular bisector, putting the two words together. If you see the word perpendicular, you can make right angles. And it's going to cut the segment in half. So you'd have that and that. Perpendicular bisector. Make sure we got our parallel lines. So we've got vertical corresponding. So this stuff. All right. If you have parallel lines, you can make sure you have these Z's as well. Your alternate and interior. That's going to be the most common one. So I could do boom, 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 create a Z there between the two parallel lines. Also, corresponding parts, congruent triangles are congruent. That means that all the sides and all the angles are equal after I get one of these guys. Okay, so normally in your proofs, if you prove that they are equal, you can then go for one of the sides. So down here is an example of marking what is given. Okay, this is the midpoint, it says. I'm proving this down here. This is an exact state test question. Okay. AD equals DC. I would just read it. AD equals DC. Boom. That is given. AB equals BC. That's already marked. BD exists. So that means that I could draw a line right down here through the center. BD equals BD. That is my reflexive property. Okay. ABCD is equal to CBD. So now I just need to figure out which one of those combos I have. This is side, side, side. I do not know anything about the angles. Once you prove they're congruent, you can say their pieces parts are congruent. That is by CPCTC. Over here's a cool little diagram. You have quadrilaterals. Okay. Anything that's a parallelogram can go down to, you have rectangles and rhombi. So a rhombus has all four sides equal. A rectangle just has four right angles. Opposite sides equal. And then a square is both a rhombus and a rectangle. Dilations. Anything has a scale factor of 1, greater than 1, it'll get bigger. less than 1, we'll get smaller. If it's 1, it is congruent. Okay, this is the only transformation that would be similar, not congruent. So it means I'd have a scale factor. This is where we go big to small. So like if I had 9, 9, and 9, 3, 3, and 3, I can go 9 divided by 3 to get my scale factor of 3, which means it's getting bigger from left to right. But it's going smaller from right to left, so we have to look at our notation. So if I'd go from right to left, it would actually be 1/3 going through that. When you're given coordinates and a scale factor, you can multiply by the scale factor first, then do Pythagorean theorem, or go backwards. Guys, hey, when in doubt, make right triangles, do Pythagorean theorem. What's the most common way to prove triangles are similar? Angle, angle. Angle, angle similarity. Okay. 90% sure you'll have proving two triangles are similar. They will be similar by angle, angle, most likely. After you prove they are similar, you can do a proportion. So this one over here is a question that we've done a lot in class. Okay, I've got a big triangle and a small triangle. So here's my small one. Right here is my big one. The first thing that we would do is add these two together to get 6 plus x. So if I go big to small, I would have 14 over 5. 14 shrinks to 5 as x plus 6, or 6 plus x shrinks down to 6. That should be a plus sign. Okay, then you could cross multiply, make sure you distribute through there. Okay, these guys are parallel. I can always do something with parallel lines. We're trying to prove a proportion. SR over PS equals TQ over P2. That's PT. That's what we're trying to find. Okay. I have parallel, so that means I have angles that are equal. PST, it tells you that's equal to PTS, or to angle R, and PTS is equal to angle Q. That's because those slide, those are corresponding. So these two are similar by angle, angle. After you prove that they're similar, you can do a proportion big to small or small to big. So that's almost like the same thing as CP/CTC. So if I have the big to small, that would be PQ over the small part. PQ shrinks to PT, which is here. PR shrinks to PS. So I'd have PR over PS equals PQ over PC. And that is by, so once I prove they're similar, I can say their corresponding sides are proportional. Triangles are proportional. Again, these would be drag and drop. So guys, I know I did not spend as much time as I like to on this section for this year, but just bear with me and do the best that you can. Okay, so now we are moving on to trigonometry. This is your SOHCAHTOA, your Pythagorean theorem, and your special right triangles, which will be on your reference sheet. Make sure you put your calculator in degree mode. We'll talk about that in class. Angle using sine -1. So when it wants sine of A, this is the sine ratio. Sine is opposite over hypotenuse, so I go A, boom. This would be O over H. So this would be 24 over 6, or 26. Or you could simplify, you could have the decimal, any of that. Now, if you want the actual angle measure, the measure of angle A, you would have to do sine -1 of 24 over 26. Okay, that answer would go here. Whatever that is when you put it in your calculator. That's just a common mistake whenever you, like, just knowing the difference, it will ask most likely for what is the sine of A. Do not put the actual angle measure. It wants the fraction. Okay. Where's the angle for circles? We didn't do as much of this as I wanted to. Where's the angle? Center was the same. So something like this, if I have a circle, if this is 90 degrees, if the arc is 90 degrees, that would make this 90 degrees. Obviously that's not. But then if it's on the circle, it is exactly half of that. So that would be 45 degrees. It's smaller than the interior angle there. Inside, you average them. We did not get to that. Outside is big minus small divided by 2. Again, I haven't seen that very often on the state test, but yeah, we might do that a little bit after you take that. This is called a chord. Crosses through. A secant goes all the way through and continues. A tangent just crosses once. Also, if it says something is a tangent, it would meet at a 90-degree angle. Tangent meets at 90-degree angle. Area of a sector going through that. Okay. Arc length deals with the circumference. So if I wanted this red piece right here, circumference is pi times diameter. All right. So then I could do, I don't want 100 or 360. I could do 100 degrees over 360 degrees is equal to my arc length. So my length over pi times diameter. If the radius is 7 centimeters, my diameter would be 14 pi. So you could cross multiply here and solve for L for the area. Area of the sector. So that means that you want the actual area of this piece, not just the crust, if you will. So that's when you take 100 over 360 equals my area over that, the whole pi r squared. So if this r squared would be 49, so this would be 49 pi. Same thing, I could cross multiply and solve for A. Now I'm going quick. All right, equation of a circle, center -3, 5. That's when you take the opposite, x plus 3. Since that's your x value, that's your y value, squared plus y minus 5 squared equals squared squared. You have to square your radius. That is your equation of the circle. To complete the square, you get x's and y's together on one side. You take half of -4 and square it. That's what goes in half of this b value. Half of the b value. That's where this 4 comes from. For the y, you take -6 divided by 2 and square it. This is what we did in the first 9 weeks. Okay, I know it's been a while, but then these rectangles, whatever you do to one side, you also have to do to the other. So we have to balance both sides. Okay, and then this brings back our factoring. Remember those x's, 4 on the top, -4 on the bottom. It multiplies the 4 and adds to -4 would be -2 and -2. So there's 2 -2's, or x minus 2 squared. Square root of 4 is 2, square root of 9 is 3. Again, we'll do some more of those. All right, we've got volume. You'll have a reference sheet. Bases and heights are always connected at 90 degrees from there. Here are your areas. That will be on a reference sheet. When given a slant, make sure you use the Pythagorean theorem. Two parallel bases. If they don't, make sure you use 1/3. Density is mass per unit volume, as I just said to you guys in class. Per means to divide. Density, mass per unit volume. In 2014, the population of Hong Kong estimated this. City covers approximately this square miles. what is the probability of people per square mile? So whenever you read it, people per, it should be people over miles squared. People per square mile. So I'm going to take the people, 7, 1, 1, 2, 6, 6, 8, 8, and divide it by my miles squared, which would be 426.25. This is people, this is miles squared. As long as you read people per mile squared, you should be able to get that. This is also what we just did. And means to multiply, so this would be probably A times probability of B. And means to multiply. This is called the intersection of the two. Pretty much means to multiply. Union. So this down here, the U means union. So think combining two things together. Like in a marriage, they say two become one. You just are combining. It's every possible situation together. So or would be probability of A plus the probability of B. Or means to add. And then subtract the overlapped. This is conditional probability, most likely going to be a table. We did not do this very much in class. Actually, not at all. Okay? But most likely it's going to become a table. This is an exact question we did in class. So when we're doing this, when we read this, the probability, we need to get one number from in here. Probability given the person is a female, so I'm going female here. Female is what I'm looking at. I want the probability of selecting a child. So that's this box right there. It gives me that probability, so I can go 2.25 times 120 to get that number, which would be 30. Then I'm going to see if you guys actually are listening and see if you guys complete that table. I'm going to look straight for this one to see if you guys actually watch this or not. Yay. Okay. Equations of lines, y equals mx plus b. Parallel lines have the same slope. So 2/3 would stay the same as 2/3. Perpendicular lines have the opposite reciprocal. So 2/3 would turn into -3/2 whenever you're doing that. Cross section is slicing an object. So it's literally you're taking a knife. We have not done this. But for this one here, if you were to slice this diagonally, okay, remember a square and a rhombus all have equal sides. So picture this. If I had a right triangle, this would be like the hypotenuse. Okay. No matter what, the hypotenuse is going to be different. So that's going to make a rectangle. Okay. This side here and this side would be different. So it is kind of hard to see. Okay. But just imagine slicing whatever that picture is. Graph all coordinates. Make sure if they give you coordinate points, you graph them. You can always do slope triangles and do the Pythagorean theorem and make some right triangles and all that fun stuff. Okay. Again, we will go back through and I will talk you through a lot of these things, but hopefully this will help.